All right, so I had a request to go through a few problems from our review sheet for this quiz. And honestly, some of these questions on this review sheet are even a little bit harder than the ones on the quiz, but they're practicing the same stuff. And yeah, I'll just go through a few of them. I think I posted 9 up here, but we'll see. I'm trying to keep this video to about 10 minutes, not to overwhelm you too much, but yeah, I'll give you a few examples worked out real quick. All right, so look, there's actually more examples than I remembered being on this review sheet, like number 1 here, where you have a function raised to a function. I mean, there are so many examples of this on this review sheet. So, like, for instance, number 1, number 2, number 4, number 7, number 12, number 13, number 14, number 15, number 16, number 20, number 22, number 24. I think that's it. But that's still a lot of numbers, okay? So anytime you have a function raised to a function, you do logarithmic differentiation. Now, I think there's a little bit too much of that on the review. I wouldn't stress this type of problem that much, but I will go through a couple of examples with that with you real fast. So anytime you have a function raised to a function, so a variable in both the base and the power, first thing you want to do is take the natural log of both sides. So I want to take the natural log of ln of x to the x. And the reason we do that is because power rule for logs, not the one for derivative, but the power rule for logs allows me to bring that power down front. And I'm left with ln of y. And then we take the derivative implicitly. So that's going to be 1 over y, dy over dx. And then this becomes product rule. So derivative of the first is 1, keep the second the same, plus keep the first one the same, and the derivative of ln of x. Well, that's chain rule. So first that's going to be 1 over the ln of x, and then multiplied by the derivative of the inside, which the derivative of ln of x is 1 over x. So again, to take the derivative of that was chain rule. And we can simplify that right side, but you'll notice the steps are always the same after this point. We get dy over dx by itself by multiplying by y. So we have y times, this is ln of x, plus, and honestly, the x and the 1 over x cancels out, so really all I have right here is 1 over ln of x. But remember, we do not like having just y in there. It has to be all in terms of just x. So I'm going to plug back in what y was, which was the ln of x raised to the x. And we're going to multiply by ln x plus 1 over ln x. All right, let's keep going. Just pause the video if you need to register that, but let's keep going. How about 7 to the tan of ln of 3x? This is a big boy problem here. We got chain rule, we got exponential, we got tan, we got ln, we got everything. Let's have some fun with it. Okay, look. First off, this is a number raised to a function. Or another way of saying this is an exponential. Exponential. We have a rule for taking the derivative of exponential. All right? Same thing as having a to the u, where a in this case is 7 and u is that function tan ln of 3x. So when we take the derivative, y prime is equal to, remember the steps, the derivative is going to be just 7 tan ln of 3x. So that stays the same. And then we multiply by the derivative of the inside, or the derivative of the power. The derivative of tan of ln of 3x, there's a lot of chains there, is going to be the, take the derivative of the outside, so it's the secant squared of ln of 3x, and then multiply by the derivative of the inside, which the derivative of ln of 3x, there's another chain within that, is going to be 1 over 3x, and then times the derivative of the inside of that, which is 3. So the derivative of all that power is secant squared of ln of 3x times 1 over 3x times 3. You got to do chain rule twice there. And then don't forget to multiply by, this is based off of the rule of derivatives of exponentials, to multiply by the ln of 7. Now I would leave it that way. We did the rule by rewriting the equation times the derivative of the inside, and that took us a couple chains, and then multiplied by the ln of a. And that is my final answer. Let's try another one. 5 ln of x sine of x. So this is more so like what you might see on the quiz. Product rule with natural log and sine. So this product rule because we have 5 ln of x times sine of x. Okay, one function times another function. So how we do this is we're going to do the derivative of the first, which is 5 times 1 over x, keep the second the same, plus keep the first the same, and the derivative of sine of x is cosine of x. That's it. I would leave it that way. Free response may simplify it a tiny little bit, but nothing too crazy. Now look at this. We have e to the cosecant of 4x power. Now remember that with e to u, all right, the derivative of that is equal to e to the u times u prime. Okay, that's how we take the derivative of e to the u. That's one of our rules. And just to refresh you down here, the derivative of a to the u is the same thing. It's a to the u times u prime, but we just had to multiply by the ln of a. That's the extra step if the base isn't e. And we have those 3 steps right here. All right, let's keep going. So, so this derivative y prime is going to equal e to the cosecant of 4x. We rewrite it. Then we multiply by the derivative of the inside, the derivative of the power. And the derivative of cosecant of 4x is going to be negative, I can write it, negative cosecant 4x times cotangent 4x. And because there's some quantity inside that, other than x, we multiply by the derivative of that inside as a chain within a chain, which is 4. And that is, again, it. Let's keep going. All right, cotangent over x squared. So this is quotient rule mixed with trig. So let's see what we get. This is going to be low, which is x squared, d high. Now the derivative of cotangent is negative cosecant squared x. So we did low d high minus high, and then d low would be 2x all over low, or x squared squared. And if we're taking the derivatives again, I would probably keep it that way. Not simplify it, but that's probably about as far as I would take it. Okay. Let's keep going. Pause the video if you need to, but we're going to keep going. Trying to keep it under 10 minutes, but it might go a minute over or 2. That's okay. All right, I almost didn't do this one because it's like the first one we did, but it does involve secant and ln, which is kind of cool. But notice how we have a function raised to a function. The variable x is in both the power and the base. So the first thing I need to do is take the ln of both sides. And the reason that we take, what the heck did I just write? Secant. ln secant x to the ln of x power. And the reason I do that is because the power rule for natural logs, let me bring that down. So I have ln of x times the ln of secant of x. And this equals ln of y. So again, with implicit differentiation, you want to take the derivative of both sides. And remember, taking the derivative of y is implicit. And we're going to do product rule. So it's the derivative of the first, keep the second the same, plus keep the first the same, and the derivative of ln of secant is going to be 1 over secant x, and then multiplied by the derivative of the inside, and the derivative of secant is secant x tan x. Now, the last thing you want to do is multiply both sides by y to get rid of that. And so we have y on the other side and all of this other mess. Okay. But remember that we do not like to have y in there, so I'm going to rewrite y as what we originally started with. And I already forgot what that was. Secant x ln of x. So this is y is the same thing as secant x to the ln of x power. And then we rewrite everything from before. All right, very nice. So now I'm going to do that. That's going to do it for the logarithmic problems. I'm not going to do any more of those. But I do got, so I'm going to skip, I'm actually going to skip number 20. That is just like the last example we did, but we got, because we have a function raised to a function. But the reason I chose this one originally is because I wanted us to take the derivative of a log. We've done ln, we've done e to the x and a to the x in this video, but not log base a. But I did put one of those in number 27. So that's pretty good because the last two are going to be practicing finding the inverse derivatives, so practicing those rules. Okay. So we'll skip 20, but we'll go to 25. 25 is the arc secant of x plus 3 to the x. So we literally have two rules for these. We have one rule for trig inverse, and we have one rule for exponential. And this is an exponential where we have a to the x. Okay, so let's practice each of those. So the so it's just arc secant of just the quantity x. So that's pretty much just rewriting down the formula. Okay, the derivative of arc secant is just 1 over, and then hopefully remember from our chart, x square root of x squared minus 1. And then plus, again, 3 to the x is just a formula, or there's just a quick little rule for that. So the derivative of 3 to the x is going to be 3 to the x multiplied by the derivative of the inside, and that's just x, so we don't got to write that. But so then we just multiply by the ln of a, which is 3. So that's it. It was just two shortcut rules that we had to know. And then lastly, the one that I wanted to do was, this was a good one. This is a chain with log and with tan inverse. So it's practicing a lot of cool stuff. All right. First off, let's start with the outside part of the chain. And let's remember the rule for log. So log base a of, we'll say u, if it's anything other than u, which in this case it is. Remember, it's equal to, it's the same as natural log. It's going to be 1 over u times the derivative of u. So just like ln of u. But then remember, the only difference is that we have to multiply for log 1 over the ln of a. So in this example here, what we do, state the derivative, we're going to do 1 over u, or 1 over tan inverse of x, multiplied by the derivative of u, so the derivative of the inside. The derivative of tan inverse is 1 over 1 plus x squared. And then we're going to multiply by the ln, or 1 over the ln of a, or 1 over the ln of 5. Boom. So I just wanted to give you a quick video practicing a few of those problems with log, natural log, exponential, a to the u, logarithmic differentiation, tan inverse, chain rule, product rule, quotient rule. We just did it all. So I encourage you to try the rest on your own. Try these again. Look over the answer key that Mrs. Vedder posted on this day. It was all this is from this day right here. Particles in motion and Unit 2B quiz review. So that's on 10/5 that day. And all I did was pull those questions from right here. So good luck. If you have any more questions, please let me know. Y'all have a great day.